En esta oportunidad tenemos al profesor Timothy Williamson de la Universidad de Oxford. El profesor Williamson es actualmente uno de los filósofos más influyentes en el mundo. Algunos de sus trabajos más importantes son Knowledge and Its Limits, que lo tengo acá, Identity and Discrimination, Vagueness, entre otros. Y el día de hoy nos va a dar la charla Knowing by Sight and Knowing by Proof. So Tim, whenever you're ready.
Okay, good. Nice to be here remotely, and so this talk is it's partly about the distinction between a priori and a posteriori knowledge, but it's also about the way in which knowledge by perception and mathematical knowledge are much more closely related than you might think. Okay, so I'm taking knowing something by sight as a paradigm of a posteriori knowledge, and as it were, the usual phrase is that it's dependent on experience. Whereas knowing by proof is a paradigm of a priori knowledge. It's independent of experience. And so the challenge is to show that these are actually much closer than you might think. And of course, these phrases "dependent on experience," "independent of experience," that they would, in principle, they need quite a lot of elucidation. What kind of dependence are we talking about, and what kind of experience do we have in mind? So, after all, I mean, going through a proof is itself an experience, in some general sense of experience. So what I am going to be arguing in this talk is that that the distinction between a priori and a posteriori it's superficial. It doesn't cut, as it were, at a natural joint. That's not to say there's no distinction at all, but just that it's kind of on the surface. So what I'm not going to do is to discuss definitions of a priori and a posteriori in detail. I'm not going to approach the subject in that way. And I am going to allow that some knowledge is a priori and that some is a posteriori, so that there, as it were, it's not a distinction with everything all on the same side, which would be, of course, pretty useless. So what I'm going to argue is that the paradigms of a priori knowledge are so close to paradigms of a posteriori knowledge that the distinction is much less informative than epistemologists usually take it to be. So I want to say a bit about, as well, this kind of form of argument, because it may not be so familiar. So let me give some other examples of distinctions which are genuine but superficial. So I mean, here's one: just the distinction between red bicycles versus non-red bicycles. I mean, there's perfectly genuine distinction, but I mean, it's superficial. Actually, you know, in both the literal and, as it were, the once metaphorical sense, that I'm not sure that I can let this person in because I think I may lose control if I do that. But yeah, yeah. If I'll leave that to you. Some bicycles are red, some are not. But you can, after all, you can turn a red bicycle into a non-red bicycle just by painting it. And another one, maybe of some slightly more interest, is the partition of all humans into races. And I mean, it would be possible to do that, but just by some stipulations about, as it were, what DNA counts as making you a member of what race. I mean, you could in principle have some kind of criterion. I mean, a more or less arbitrary one in terms of DNA that would have the effect that all humans belong to exactly one race. But I think it's fairly clear that that would be, a fairly superficial distinction. Not one that told you very much. Even though it would be genuine, because it would actually correspond to real differences of some sort between people's DNA. So let me just see what's going on here. Sorry, can I just... Yeah, so let me just say just a little bit more about this before I go on. So what would be superficial about these distinctions could be brought out by taking a red bicycle and a non-red bicycle, I mean, let's say a green bicycle. So one is a clear example of a red bicycle. The other is a clear example of a non-red bicycle. But still, the difference between them could be very superficial. I mean, because in effect, one could just be the other having been painted green. And you could do something like that. You could have a clear case of somebody who was on one side of the distinction between made according to the DNA, but and then a clear example of someone who's on the other side, and yet the differences between them were simply not interesting ones. And so again, although these distinctions are in some sense genuine, they're pretty superficial. They're not the kind of distinctions that we would be interested in some kind of useful taxonomy. Okay, so now what I want to do is to get on and to discuss the case of proof in mathematics. Let me just check that I've got the right things here. Yeah, okay. So here's the kind of situation that I want you to imagine. Imagine a mathematician who has done a proof of a new theorem. But it's late at night. They're tired. They're not sure. At the moment. They're not sure whether the proof is correct or not. But they're tired, so they go to sleep. And the next morning, they're going to go through the proof that they've written out in a notebook to see whether it's a correct proof or not. So this is an example, as it were, of something which is supposed to be a paradigm of a priori knowledge, which that's knowledge by mathematical proof. I mean, that would seem like a classic example of a priori knowledge. So and let's as it were sort of zoom in on a particular step in the proof that they're checking, and so and let's just suppose, for the sake of argument, that this is a proof by, a step by modus ponens. So it's of the form, if A then C, and A therefore C. And so it's something like we've got on the right hand side. If n is greater than 24, n is prime. N is greater than 24, therefore n is prime. And so the mathematician has to check that this is that what is in front of them is indeed a genuine proof by modus ponens. This particular step of the overall proof. Now, what seems to be going on here is, in fact, some kind of pattern recognition, which involves visual recognitional capacities. The same kind of capacities that might be used, for example, by a chess player who looks at the board and recognizes, let's say, that the position is a win for black or something like that. So it's some kind of rather abstract pattern which is being recognized here. And one question that we might actually raise about this is, well, is it a pattern is the pattern that they're recognizing one for modus ponens in general, or modus ponens for a particular language? But it can't really be that your recognitional capacity is for modus ponens in general, because that would mean that you had to understand, well, in particular, the word for if in every language, which presumably nobody does. And so what we're talking about is something much more specific. It's a pattern for modus ponens in some particular language. I mean, in the case we've got here, it's in English, but of course it could equally well be in some other language, or including in a formal language. Yeah, so I've already made the comparison with pattern recognition in chess, and it's also it's sense specific. It's visual, or for example tactile, and in both cases, normally with you can't recognize a pattern in chess in the tactile way, because a white piece and the corresponding black piece feel exactly the same, and similarly, of course, if we had modus ponens written in Braille, the language of the blind, then you could recognize it by, well, somebody who knew Braille could recognize it by tactile means. But we're talking about a specifically visual recognitional capacity here, and when we think about exactly what it is that you're recognizing, well, it would be quite natural to say that what you're recognizing is something like an instance of modus ponens is written there, as it were, the there being a perceptual demonstrative for pointing at a particular place on the page. But of course, that an instance of modus ponens is written at that point on the page is a classic example of a posteriori knowledge. So, you might say, all right, but this needs to be a priori. So maybe what you're recognizing is somehow this is an instance of modus ponens, where this is pointing at the particular instance and not at the place on the page. That maybe there is some sense of this is an instance of modus ponens in which it does count as a priori. I'm not excluding that, because I want to allow that there is some kind of distinction between the posteriori and the a priori. But I think it's already, if we say that an instance of modus ponens is written there is a posteriori, whereas this is an instance of modus ponens is a priori, it's clear that we're already getting into a position where the difference between the a posteriori and the a priori case is very slight. And in particular, they seem to be known in extremely similar ways. So, in this case, which is supposed to be a paradigm of a priori knowledge, we're already doing something which is extremely close to a posteriori knowledge. So, of course, one thing that you might say on behalf of the distinction is, well, all right, but this is coming about because you assumed that the mathematician had written it all down and was checking what they'd written on paper. But in principle, can't the mathematician just do it in their head? And if they do the proof in their head, isn't that avoiding the kind of problems that I've been discussing? So I think that's not a very good response for a number of reasons. I mean, one is that the kind of surveyability of a proof that's required is actually in some cases it may be beyond the limits of consciousness, of human consciousness. So doing it in your head may not be a practical possibility. And one thing to remember there is that it's not just a matter of checking each individual step. It's also a matter of checking that all the different steps fit together into a single proof of the conclusion. And that, as it were, integrating function is something we can't just do in an ordinary step-by-step way. We need something as more inclusive that paper allows us to do. And bear in mind that in modern mathematics, proofs, when you get the whole proof, it can be, in some cases, it can be hundreds of pages long. I mean, of course, it's not usually as long as that, but that's perfectly possible for mathematical proof. And so it seems like you certainly can't, even with proofs that only go on for a couple of pages, you can't hold them all together in a single act of consciousness. And checking them does require, as I say, the making sure that all the pieces fit together, and actually doing all of that in your head is a task that may be too demanding for human beings. And so that as it were, that writing things down is actually fulfilling a more essential role than you might initially think in knowledge by proof. And so I've put here the irrelevance of superhumans. So let me explain what I mean by that. So we might think, well, look, all right, we can't do these things in our heads, but surely in principle, there could be superhumans who did do them in their heads, who with, as it were, just vastly greater short-term memory or consciousness than we have. So I think let's allow that in principle there could be such superhumans, but it's important to see that the possibility of such superhumans doesn't really make any difference to the status of our mathematical knowledge. I mean, if the superhumans could know it without reliance on writing, that would be a fact about them. But maybe once we've checked the proof, we could also know that in principle there could be superhumans who could verify this proof in their heads. But that doesn't mean that we have verified the proof in our heads, because our only reason for thinking that the superhumans could verify it in their heads is that that we have first verified that there is a valid proof here, and then given that there's a valid proof, with maybe we can infer that in principle a superhuman could validate this proof in their head. But our knowledge that a superhuman could do that is still dependent on our knowledge, which depends on writing that the proof is valid. So as it were, just by imagining these superhumans, that doesn't enable us to kind of bootstrap our knowledge into knowledge that doesn't depend on writing and that visual element. And I think a second kind of reason why writing when written proofs are extremely important is a quite different one, which is that mathematics is part of science, and science is something whose role is supposed to be, that this is something like knowledge that is in principle publicly available and publicly checkable, just as within physics and other natural sciences, proofs, experiments have to be repeatable. In mathematics, so proofs have to be checkable, and so it's not enough that somebody says that they've gone through the proof in their head. We need a proof in writing just for the public function of checkability, and also, for example, there are mechanisms that require this, like journal refereeing and so on. So those are some reasons, both to do with the limits of human cognition and with the publicity of mathematics, for thinking that actually having a proof that's on paper or on some public medium such as that is actually much more important than it might look. But I think there's a further, possibly deeper reason why. So we don't really get anything much out of the idea, well, we could in principle do this in our heads. So what we can think of the difference between seeing it on paper as it were, using our cognitive faculties online in perception, and using them offline in imagination. But typically, we're talking about the very same cognitive faculty, but being used either online or offline. So in effect, if we're checking that this is really an instance of modus ponens, then what we're doing when we check it offline in our heads is just we're imagining an instance of modus ponens and using our visual capacity for recognizing instances of modus ponens offline. But it is only the offline analog of what we're doing online. And so because of that close relation between the online and offline applications of cognitive faculties, what we're getting by doing it in our head is really nothing like as different as you might think from what you get by doing it on paper, except in terms of the kind of limitations of doing it in your head that I've been talking about. So in a way, doing it in your head in certain respects, it's just worse than doing it on paper. I mean, the main advantage of doing it in your head is just that it's sometimes quicker that way, when you don't actually have to write things down, and quicker and more convenient. And I think, again, we could use the chess analogy. So the online thing there is actually looking at a chessboard in front of you and seeing, some feature of it, by pattern recognition, seeing that let's say that this is a win for black, and if you do the same thing in your imagination, which maybe two experienced chess players could play a game just in their imaginations and just saying the moves to each other or something, but you would just be imagining the chessboard and using the same capacity for visually recognizing a win for black, but using it offline rather than online. So, although somebody could say, well, if you do it online, it counts as a posteriori, and if you do it offline, in the imagination, it counts as a priori. But maybe, but that would not be a very deep difference between them, given how much of the cognitive faculty is actually the same between the two cases. Okay, so now I want to move on to a kind of a different line of defense of the depth of the a priori, a posteriori distinction.
Sorry, Tim, can I ask you a
Yes,
question?
yes, absolutely. Go ahead.
Yeah, so I was wondering whether someone could reply to your example of the modus ponens by saying that the role experience is playing in the case of perceptually recognizing an instance of modus ponens is more like a causal role or like an enabling role rather than an epistemic or evidential role, which is what experience usually play in the cases of perceptual knowledge.
Yes, I think what I'm going to say now may actually help to address that issue, because I mean, the kind of objection that I'm concerned with is one which says, well, look, we need to make some distinction between form and content, where what we're concerned with is just where the form is, as it were, the specifically visual aspect, let's say, of an instance of modus ponens. Whereas the content has to do with, as it were, the actual, the logical properties of the contents expressed. And where the idea is, well, when we're really grasping a proof, what we have to do is to abstract away from the form and just focus on the content. And so, as it were, so the value of the proof was where just is all at the level of content. So I'll go on a bit, and then when I've as I talked about the form versus content issue, then maybe if you're still feeling dissatisfied, you can come back again. But I think the way I'm thinking that this maps onto your question is that as it were, the enabling role of the form is precisely just to enable you to engage intellectually with the content.
Right. Exactly.
Yes. Yeah. So one thing that as it were is relevant about the value of a formal proof is that it's mechanically checkable. That as it were, in principle, a computer can just go through it to check whether it's a valid proof or not. And if we think about, for example, modus ponens in that way, that what the computer is doing is it's not checking the content. It's checking the form. That's what enables this kind of mechanical checkability that for example, Leibniz was already had some conception of. And this, in fact, this applies to natural deduction rules, introduction rules and elimination rules in general. That in effect, when you see the natural deduction rules laid out, what you're being given are some very abstract patterns which you're learning to recognize. So, insofar as we're concerned with the issue of mechanical checkability, which is where the point of formal proof is supposed to be, that really does seem to have to do with form and not content. Now, of course, the thing is, for experienced mathematicians, that they just focusing on the example of modus ponens will seem unrealistic, because as well, they mostly don't need to drill down to that level of detail, because they're used to working with much, if they're good experienced mathematicians, with much more macroscopic patterns in proof checking. But I take it that that as it were, the difference between the microscopic low-level patterns and macroscopic high-level patterns is not so large. So I think it's not in principle so misleading just to look at a very simple case of modus ponens. And of course, there's just the issue of the need in mathematics for perspicuous notation has a lot to do with this kind of need for pattern recognition. I mean, when perspicuous notation enables one to recognize patterns much more easily, but as it were, it's formally better, even though it makes no difference to the content. Now, I mean, you might think, well, but how relevant is that to contemporary mathematical practice? But actually, it's very relevant, because the one feature, I mean, it's not that all mathematical proofs these days need this, but for really difficult mathematical proofs, there's increasing use of what are known as proof assistant programs. I mean, these are programs where you feed in your proof in whatever form you have it, and where the program doesn't understand what you're saying, or I mean what you've written down, or doesn't understand why a certain move is being made, then it prompts you to clarify, and maybe to give definitions of terms you've been using that you haven't previously defined, or to fill in some detail about the step. And what you tend to have is a kind of interactive process between the program and the mathematician, in which the program, which is itself, as it were, pretty as it were intelligent, is prompting for clarification, and the mathematician is doing their best to supply it. And then what you hope is you get to a point where the program says this proof is okay, as it's got, you manage to clarify it to the point where it can check everything. But of course, if things go badly, what will happen is presumably it gets to a point where the program is basically asking the mathematician, how do you get from here to there? And the mathematician is unable to fill in the gap, and then presumably realizes that the proof, that at least the way they currently understand it, is simply inadequate. And I mean, an example of somebody who's recently produced a proof in something like this way is Peter Schulze, who's one of the most important younger generation mathematicians in the world, who had sort of sketched a proof of some result, doesn't matter what, but the proof was so complicated that he really wasn't sure whether it was correct or not. And then he spent, as it were, maybe a couple of months interacting with this proof assistant program, and at the end of that process, he had a proof that he knew was correct. The program was happy with it, and he had some understanding of how the proof worked, but not sufficient for him to be to know on that basis that it was correct. So that this kind of role for formal proof is something that it's not a kind of external imposition by philosophers, or maybe by mathematicians like Frege with rather a philosophical bent. It's something that is there in contemporary mathematical practice for not for philosophical reasons, but just because the proof checking it has become, in some cases, just too difficult for unaided humans. So in a way, formal proof it is still operating as the epistemic gold standard. And it's often we don't actually need we don't need to produce the bar of gold. It's it's enough to hand over banknotes or use a credit card because we've the sufficient as it were trust that these well-based trust that we don't actually need to go to the gold standard, but it's there in principle, and formal proof actually does it does require that this kind of formal checkability, that's what makes it something a formal system, that there is actually a mechanical procedure for determining whether anything is a proof within that system. So as well, the idea of somehow abstracting away from the form and just getting left with the content, and then as it were the real work of understanding the proof is at the level of content. It doesn't really make much sense, because it's the form itself that we use when it really comes down to it in checking the proof. So I think it's worth asking, well, if form is so essential, then why do we have the illusion that form is irrelevant? So I think one thing is just that, of course, I mean, something that's a matter of common experience is that the same proof can be written in many different languages. I mean, we can write the proof, in a mixture of English and formal mathematical notation, but we could also write it in, different notation. You could use the word say as our conditional rather than if, or we could use an arrow, and the proof will be equally good in any language that has these basic expressive capacities. Actually, maybe the arrow is a little bit better than the natural language conditionals, but because the kind of the pointing arrow does kind of convey conditionality a bit more vividly. But we can do absolutely fine just using a natural language conditional. And so when we have a proof that there's no particular language that is essential to it. Actually, let me just go back a bit. But the fact that no particular language is required doesn't mean that language itself is irrelevant. It's like a story that maybe you tell the story in English, you tell the story in Spanish. Those are equally good, and you can tell it in let's say any other human language. But that doesn't mean that you can tell the story without using a language at all. And so, as it were, the idea that the form, the linguistic form that we put the story into is irrelevant is an illusion in that case. And I think it's rather similar with the illusion that form is irrelevant in the case of mathematics. And I think another consideration that points in that direction is the role of free variables in proofs, because I mean, that you see that all the time in mathematics, because you see lots of x's and y's and thetas and so on, which are being used as variables. And what's the point about that is that if you have an equation with variables, let's say y equals x squared or something like that, because these are free variables, that equation doesn't express any particular content itself, because no particular value has been fixed for the y and the x. So in those cases, there's a specific obstacle to abstracting the content from the form and leaving the form behind, which is that there isn't really a proper content there. I mean, maybe you could do something with the idea of arbitrary objects or something weird, but just by normal standards, there isn't a proper content there that you could abstract to when you have free variables, because you simply haven't determined which object they refer to. And so, if you have something like I've illustrated here on the slide, that, if fx, then c, fy, therefore c, that's not a correct proof. And it's not a correct proof, even if it so happens that there are some constraints which in fact determine that the relevant value of x is the same as the relevant value of y. But that doesn't make this proof valid. So just as it stands. So I think this idea of, as we're using, that the form just plays an enabling role, that it enables you to abstract to the content. It doesn't really fit with the way that proofs are normally checked in mathematics. And what I've been saying about proof checking, I think, also applies to proof construction, because proof construction is a process that involves lots and lots of proof checking as you go along, because you're constantly checking the lemmas that you need, that you're going to build your overall proof out of. So proof construction is not really fundamentally such a different case from proof checking. Okay, so before I go on, let me just ask: do you want to come back on this issue about the formulas and the written form being just enabling rather than actually evidential?
No, I think it's clear now. Thank you.
Right, thanks. So I want to talk now about some broader issues about where these matters might fit in with, for example, issues about some broader issues about human cognitive capacities and how we come to have them, and that includes issues about how we might have a have evolved, a faculty for a priori cognition. Because some people, for example, somebody I've been engaging with in epistemology quite a bit in the last few years is Paul Boghossian, who appeals to these intellectual seemings to explain a priori cognition. What I think would be a bit suspect is, if somebody was postulating some special cognitive faculty whose, as it were, sole purpose was to provide a priori cognition. I mean, it's not impossible, but it's somewhat hard to see how such a faculty would have evolved. Whereas, I think if we think of what's going on in a way where the kinds of cognition that are involved in something, which may in some way even count as a paradigm of a priori knowledge, like mathematical proof, as very closely related to things like visual pattern recognition, it's much less surprising that we would have such faculties. Now, of course, it's one has to be a bit careful with evolutionary arguments, because it's not the case that, as it were, everything that we have must have its evolved because in some way it made us fitter. I mean, there could be what are sometimes called spandrels, things which, as it were, they're just byproducts of something else, which is what increases fitness. And then we just something else comes along for the ride, and I think you can even see a bit of that probably in logic, where what is probably really does have some evolutionary value, at least of a direct kind, is the capacity to make deductions from kind of contingent premises that to contingent conclusions. So if you know that the rabbit went this way or that way or the other way, and that it didn't go this way or that way, then you can deduce that it went the other way. And so it's that logical deduction is useful from contingent premises to contingent conclusions a lot of the time. And it just so happens that the simplest way of building a creature that can make logical deductions from contingent premises to contingent conclusions also enables it to derive some logical truths. So as it were, it's a kind of just a byproduct of our ability to deduce from the contingent to the contingent that we can also derive logical truths, even though there isn't much fitness value in the logical truths themselves. So I think also in this connection we should about cultural evolution, and it's quite useful in this connection just to think about the origin of mathematical proof, which seems to have been with Euclid's geometry. That's the first case where we've got something like a recognizable mathematical proofs, even though in fact not all the proofs in Euclid are correct, but definitely there is some conception of a mathematical proof and ability to prove things mathematically in Euclid. But if we think about where geometry came from. The kind of thing that geometry came from, I guess, in ancient Egypt and Babylon and so on, is, things like you want to estimate how much wheat a given field will produce, and so if you have some geometry and you measure the sides of a field, you can then calculate the area of the field, which is what roughly speaking, will correlate with the size of the crop that it yields. So geometry, it evolved in that kind of very practical way. Even though it then led on to this much purer mathematical proof that non-Euclidean should be non-Euclidean there. So of course, you have to be careful in this area, because geometry, it started as a study of physical space, as it were, abstract features of physical space. But if you look at geometry as a branch of contemporary mathematics, it's not really concerned with physical space at all. It's just, you have various axioms, and then you're concerned with the consequences of those axioms, and so what you have is just, in effect, generalizations about all models of the given axioms. And if you think of it that way, there's no conflict between Euclidean and non-Euclidean geometry. They're just theories about different models. But we can talk about, mathematicians often talk about abstract spaces in this connection, but certainly geometry came out of the study of physical space, and that's also one of its important applications. And so, as it were, there was a long period during which mathematical proofs were being given, but they were still thought of as, in some rather abstract way, concerned with physical space. So historically, it's not as though you only had mathematical proofs after you ceased to think of the mathematics as concerned with something like physical space, which we might think of as, in some ways, sort of a posteriori. And I think another kind of clue as to what's going on here is the role both of diagrams and of spatial metaphors in mathematics, as when we talk about mathematical spaces, because these are things which are very, very highly valued by mathematicians. It's not as though when you get to sophisticated mathematics, then people don't want diagrams anymore. Mathematicians always like diagrams, as long as they have some relevance. And I think it's clear that these diagrams are there because they enable us to apply our capacity for spatial and, in particular, visual thinking to problems, and so these kinds of connections between mathematics and what you might think of as pre-mathematical cognitive capacities, like spatial intelligence and so on. These are very visible in the history of the subject and in its contemporary practice. So, we shouldn't be surprised at these connections. And of course, what I've been saying, it's given quite a significant role to the imagination, because I've been, when I was arguing that when we do mathematics in our head, we're doing it as we're using our imagination, and that's basically the offline equivalent of the online use of perception. And so if we're thinking about, so how is something like this intelligible from an evolutionary point of view? I think one useful case to consider is that of decision making, because in decision making, we have to consider what the consequences would be if we took, a certain option, and then maybe compare that to the consequences if we took a different option. And we've got, in some way, to be able to work these out in the imagination, because it maybe you can't always do this by trial and error. You try one thing, and then if that doesn't work, you try the other thing, because sometimes it's a matter of life and death. And if you try the wrong thing first, then you're dead or you're injured or whatever. And so one important value of the imagination from an evolutionary point of view is that it enables us to test and compare alternative courses of action in our heads, as it were, quite quickly. And this may be something that some non-human animals are capable of doing. So, I think the evolutionary value of being able to apply cognitive processes that originally you just applied online, to apply them offline as well in the imagination. I mean, it does have a clear value in cases where trial and error is not an option. Something else that I'd like to talk about a bit is the relation between the a priori, a posteriori distinction, and the distinction between the innate and acquired. Because you might think, well, look, surely there's a good distinction between what's innate and what's acquired. And if the a priori, a posteriori distinction maps onto that, doesn't that confer some respectability onto it? So, I mean, I should say that there are lots of different competing ways of distinguishing between innate and acquired as well. So that distinction isn't as problematic, isn't as unproblematic as it sounds. But also, I don't think that if we do try to connect them, it's going to give us a distinction between the a priori and the a posteriori that works in the way that we'd like it to. So, for example, there's some evidence that human beings have something like innate knowledge that snakes are dangerous. I mean, it seems we have an innate fear of snakes, or as it were, or things that look like snakes. We might take that to be, in effect, innate knowledge that snakes are dangerous. But certainly, the knowledge that snakes are dangerous is not, at all the kind of thing that the philosophers have had in mind when they were talking about a priori knowledge. And I think one reason why they don't really fit very well is that although the knowledge that snakes are dangerous, it may be innate in a given individual, but nevertheless, it seems to be, a classic product of experience, on the part of not just of that individual, but of the members of the species as a whole, and maybe possibly even then pre-human ancestors. So that, as it were, creatures who do have an innate fear of snakes, that makes them fitter than creatures who have no innate fear of snakes. So it looks as though just trying to map the a priori, a posteriori distinction onto the innate acquired distinction is not likely to give us something that is going to be terribly interesting from an epistemological point of view. So that's what I was just saying, that in effect, on the innate side, we would get things that involve learning from interaction with the environment at the level of the species rather than just at the level of the individual. So if we're thinking about the particular case of modus ponens, then, well, it's quite clear that modus ponens for English it is not innate, because people are not born with an innate knowledge of a particular language. They may well be born with an innate capacity, of the kind that Noam Chomsky talks about, to learn a language with, if you like, with some kind of understanding of what the structure of their language will be, but it's not for a particular language. So it doesn't look as though they're going to have modus ponens for English or for Spanish or for anything. But you might think that maybe they have innate modus ponens for some kind of language of thought, which people sometimes call mentalese, in the sort of thing that Jerry Fodor imagined. But that isn't the same thing, because when we're consciously reasoning, we're not using modus ponens for mentalese. We're using modus ponens for a natural language, and that's a thing that isn't innate. So it's very doubtful that the innate acquired distinction is really quite what we need here, and I don't think it's going to kind of rescue the a priori, a posteriori distinction as something of real depth. So we might just say a few words about why the distinction between the a priori and the a posteriori should seem deep, even if it isn't really deep. So, of course, the kind of cynical answer would be that this is just some kind of historical deference to, the great figures of the past, like Immanuel Kant and so on, with whom the distinction is associated. But I think there's more to it than just that. I think that one way in which the distinction at least appears sort of very palpable and clear is that there's a distinction between, on the one hand, thinking, where we're typically, as well, at least if we're thinking, as it were, with your eyes shut and not listening to outside sounds and so on, that's something that can be done just in some sense internally, whereas perceiving, overtly involves interaction with the environment, and so does acting normally. I mean, all normal cases of action involve interaction with the environment. So there are, there's a kind of blatant difference between some kinds of mental act which directly involve interaction with the external environment and other kinds which don't. And that might seem to vindicate the a priori, a posteriori distinction. But, and we could put it in, as it were, in computer terms, that it's a distinction between internal processing on the one hand and inputting and outputting on the other. I mean, that's a genuine distinction even with computers. But I think what's the trouble is that if we then apply that to cognitive processes, what we tend to end up doing is just classifying them by their final stage. So, if the final stage is a piece of thinking, then we tend to classify that as a priori, whereas if the final stage involves interaction with the external environment, we classify that as a posteriori. But I think it's fairly clear that if we're just classifying cognitive processes by their final stage, that is going to be very superficial, because it's not paying any attention to what happened at the earlier stages. And the nature of a cognitive process is not simply encapsulated in the final stage, which might, as it were, be relatively, minor by comparison with with earlier stages where much more of the real work was being done. So that doesn't. That distinction, although it's genuine, is too kind of short term to be useful, particularly when we're talking about something like knowledge, which concerns not just the final step by which you reached a conclusion, but what all the previous steps were as well. So that isn't really going to help us. And so an example of this would be, if you take learning that not all swans are white. Let's say that you see a black swan, and then from that you learn that some swans are black, and then from some swans are black you can infer not all swans are white. But still, your knowledge that not all swans are white, it did depend on seeing the black swan, or maybe on somebody else seeing a black swan and telling you about it, and so on. Although in that case the final step in which you infer not all swans are white from some swans are black, although the final step is on the thinking side, if you like, the a priori side, it would be crazy to say that the knowledge that not all swans are white is a priori on that basis. So, that's just amplifying the point that it's not simply the final step that counts for purposes of classification. So one final issue I want to raise is whether what I've been arguing for is some kind of empiricism, because I think some people would be very likely to interpret me in that way. But I haven't actually been arguing that all knowledge or justification is a priori, because I haven't really said anything very much about how one might draw that distinction. But somebody could draw the distinction just by saying, look, I want to take as paradigms of a priori knowledge or a priori justification, mathematical or logical knowledge or justification, and I haven't said anything that implies that that would be illegitimate. And if they took those as paradigms, then those would be a priori knowledge. So, sorry, what I've written here is not arguing that all knowledge or justification is a priori. What I meant to write there, it should say I'm not arguing that all knowledge or justification is a posteriori. Sorry, that's very misleading. So as I say, I'm not trying to argue that there is no a priori knowledge or justification. I'm quite happy just to accept that pretty much by definition, a whole lot of normal mathematical knowledge counts as that. I just don't think that that tells you very much. I'm certainly not arguing for a kind of, the sort of empiricist, the classical idea of the mind is a tabula rasa, as John Locke talked about, as whether it's basically empty until experience fills it. And I'm not even arguing for the slightly watered down type of empiricism that you get with Quine, where Quine allows that, as we're learning, requires some kind of innate similarity space for, that's needed for general inductive learning, but thinks it's very unspecific. I'm perfectly happy to allow that that there may be there may be cognitive modules of the kind that Chomsky and Fodor postulate. So as it were, if we're talking now about the, as it were, innate acquired distinction, I'm perfectly happy for quite a lot to be on the innate side. And in that sense, that this is not some kind of classic empiricism at all. It's sorry. So if we use the computer analogy, then we've got, as it were, one thing that, and as it were, an empiricist who was thinking about this might want to insist is that the inputs I experience, inputs can modify the program, and that I'm perfectly happy with that. But at the same time, the outputs that we get they may be sensitive to both the inputs and the original program. If you like, the innate stuff. So I'm not at all claiming that as well, what we eventually get can be entirely explained in terms of the input, the original program, the if you like, the innate cognitive structure that human minds have. That those can play a large role as well. And so just to conclude, I think often, people complain about the standard stereotypes of the a priori, and then that may push them into the as it were, the sort of empiricist sounding position of saying that that nothing is a priori, it's all a posteriori. But I actually think what I'm suggesting is that it might be that standard stereotypes of the a posteriori are just as inadequate as the standard stereotypes of the a priori, and so there's no more reason to say that everything is a posteriori than there is to say that everything is a priori. I think it's, as it were, the distinction between the a priori and the a posteriori. It's maybe a distinction that is okay for epistemology 101. that we have to start somewhere with some kind of rough classification of, for example, epistemic phenomena, and so, early on, distinguishing between the a posteriori and the a priori may be, a helpful thing to do, just as in very early stages of biology, maybe classifying things by color was a useful thing to do. But it has severe limitations, and I think we need to get beyond it and to think in terms of more useful ways of understanding cognitive and epistemological phenomena. Okay, so I'll stop there. I'll stop sharing, and we can have discussion.
Thank you so much, Tim. I think this talk was very illuminating. So if people in the audience have questions, I think they can raise their virtual hand.
Yeah, and will you chair the discussions, and so
sure.
Tell people.
Yeah, so I think we have Pyro.
Sure. Thank you so much, Tim, for the talk. So I have probably something as a super basic question that I probably didn't understood well. Probably you didn't address it. So how do we make sense without the a priori as anteriori? So sorry, without the a priori posteriori distinction. How do we make sense of the epistemic status of logical truth, for instance? How do we make sense of the special credence that we could have?
Yes.
Yeah.
So, in the case of logical truth, I mean, one thing I would say is, I don't think it's at all automatic that if something is a logical truth, that then it's easy, to know, or even possible to know. So, in at least in some ways of understanding higher order logic, either the continuum hypothesis is a logical truth, or its negation is a logical truth. But but that doesn't give us any way of finding out which is the true one, the logically true one. But even putting that aside, I think that if we follow what's maybe the most standard account of logical truth at the moment, which is the one that goes back to Tarski. It's a logical truth is a sentence which is true on, however we vary the interpretations of the non-logical constants in it. And that really makes the logical truth of a sentence equivalent to the ordinary truth of its universal generalization, where we kind of generalize out all the non-logical bits. And so these logical truths, they're actually, I mean, they're fantastically generalizations. And that by itself doesn't say anything very much about how we can know them. I mean, I think these are things which, there are various things you can say, for example, that because of their great generality, if they were if they were wrong, if they were false, it would be relatively easy to find counterexamples to them. And you know, it's also the case that we've, you know, the principles of classical logic have been very well tried and so on, and you know, they've done pretty well. But you know, I think I mean those may not seem terribly satisfying, but you know, I guess although people have attempted to, you know, explain logical truth in a way which would make it seem kind of epistemically easy, you know, for example, by trying to present the, you know, basic inference rules as somehow true by definition or something like that. I mean, kind of analytic. I don't think those attempts have been successful. And you know, and the, you know, and one indication of that is that it's, you know, it's perfectly possible for people to challenge any proposed logical truth. You know, I mean, you know, Graham Priest thinks that there are true contradictions and so on, and lots of people have rejected the law of excluded middle. And you know, and I think, you know, when you see their challenges, I think, you know, I think it's not at all a convincing response to them to say that well, obviously they don't understand what the word "or" means, or they don't understand what the word "not" means, or something like that. I mean, you know, the people who are making these challenges obviously do understand the meanings of their words, and so, you know, I don't think there's much prospect of you know, of kind of, as it were, developing, as people have tried to do, an epistemology of logic, which, you know, based on analyticity, and you know, in some way that would mean there's somehow there's no challenge there. So, as I say, that, you know, that's not a super reassuring response, but you know, I don't think that really that there is some, you know, some very, you know, some quick answer to the epistemology of logic there. You know, I think that you know, it's I mean, you know, one can say things, I mean, that in the realm of first order logic, where we're basically, you know, where we have a completeness theorem and all the logical truths can be derived from, you know, by fairly elementary reasoning, which is kind of, you know, has, as it were, has survived extremely severe testing. I think there's, you know, there's not much, in my view, there's not much doubt about these theorems, but but that isn't very a priori.
Well, that gives me things to think about. And thanks so much.
Okay, thank you, Pyro. Then we have a question from Eduardo.
Yeah, well, thank you very much, Tim, for the talk. So while I was listening your talk, I was remembering the beginning of Frege's Foundations of Arithmetic, in which he addresses the objection that psychologists and people who think that they can give an evolutionary account of mathematical knowledge would give. So he makes this distinction between two different projects. One project is the project of giving a history or evolutionary story about how we discovered mathematical truths. And of course, that's a legitimate enterprise. But he says that there's a very different one that in which he's engaged in, which is what are the grounds for the truth of mathematical statements. So in a way, I guess most people would agree with you that if we focus on the cognitive processes by which we acquire mathematical or logical knowledge, then probably we will need a story that doesn't make a huge difference between the way we acquire other kinds of knowledge. Because we are biological creatures and we have a brain, and of course there's a whole process or whatever that must remain some sort of similar in both cases. But I'm not so sure if people would be happy to say that the distinction between a priori and a posteriori knowledge is part of that sort of enterprise. So people might say, no, the distinction is not so much about the cognitive processes by which we acquire those pieces of knowledge, but about the epistemic entitlement that a rational agent have in those statements. So if we focus on that second project, then we can see that there's an important difference between the grounds that entitle us to knowing that modus ponens is valid, or that 1 + 1 is 2, and they're different, and they're different from those grounds by which we are entitled to know that bicycle is red, for example.
Yeah, I mean, so the thing is, of course there's a difference between how we in fact come to believe something and how we could come to believe it. So it's possible that we come to believe it, we come to believe something in an a posteriori way, but we could have come to believe it, or we could still come to believe it in an a priori way. That's possible. But the question is whether we're actually being offered some alternative route that that's available to us for knowing these things in a much better way. And if you take something like knowing that 2 + 2 = 4, it would not be plausible to say that we now know that 2 + 2 = 4 in a completely different way from the way in which which people before Frege knew it, or something like that. And so, of course, one thing obviously is, whether Frege succeeded in offering some alternative route, and there, it is relevant that the system of the Grundgesetze turned out to be inconsistent, and that and if you try to reconstruct it. You're going to have to, for example, you're going to need some kind of axiom of infinity that says that there are infinitely many things, and where it's what the grounds are for such an axiom is not at all clear. So that I don't think that that Frege was really was providing something that was kind of radically different from what went before. I mean, it may be that some version of his logicist project can succeed, but I think if it does succeed, it'll be because logic turns out to be to include a whole lot of things that wouldn't originally have been thought of as logical, e.g. an axiom of infinity that's not derived from anything else, and so that the the question of how we know these logical principles from which we then derive the rest of mathematics is itself a tricky one, where the logical principles may be maybe fairly plausible, but of course that doesn't get you very far, because the axioms of Frege's Grundgesetze were fairly plausible, but they led to a contradiction, and so I'm not suggesting that his kind of project doesn't add anything at all to our epistemic position, but I don't think it transforms it to the extent to which maybe at one time Frege and Russell and other logicists hoped that it did. And I think it's quite interesting to look at where Bertrand Russell ended up, because I think originally he was sort of hoping that the logicist project would put mathematics on a completely indubitable foundation, but by the time that he'd worked through the paradoxes and so on, his kind of view of the status of mathematical knowledge was what we would now call abductive. I mean, he calls it inductive, but it's clear that he meant pretty much the same thing. That he thought that the things that are really the most certain in mathematics, are things like 2 + 2 = 4, not like the logical principles that in Principia Mathematica you use to derive 2 + 2 = 4, and that those kind of, as were the first principles, what their epistemological status doesn't come from self-evidence. It comes from the capacity to generate the bits of mathematics that we already know, which themselves were derived but by an abductive process from lower level things and so on. And so I mean, Russell I think found himself pursuing something similar to Frege's project, found himself having to give this I think quite plausible but abductive story about the status of mathematics, but one which I don't think is incompatible with the kind of thing that I was saying. I mean, that mathematics does play this kind of role, and acquires a certain kind of autonomy, so that in the further developments of mathematics, we're not trying to explain physical results of experiments or something, but directly, but we're just trying to explain lower level mathematics and so on. So so I think that although we can, through the kind of process that Frege and Russell were engaged in, we can, do something to improve our epistemic position in mathematics. We can't transform it to the extent that maybe originally seemed possible, when it looked as though, we might be able to just derive all of mathematics from completely self-evident principles or something like that.
Can I ask a brief follow-up?
Yeah.
On that? Yeah. So, yeah, I think I understand your point, and I think I agree on what you're saying about Russell and Frege, but quite independently of their results or their theories. Maybe what I was trying to distinguish is between a project that has the cognitive processes by which we acquire a certain body of information, and the project of focusing just on that body of information as something that we know, right? But disregarding the processes. So your if I understood it correctly, your proposal has to do with the first project, right? Because you were emphasizing the process of checking whether a proof is correct or not, and the process of constructing a proof, and those are, of course, cognitive processes that we engage in, and that's fine. So in that project, there's probably not a huge difference between the a priori and a posteriori difference, but maybe on the other project, in which we don't care about the means by which, or the processes of constructing or checking a proof, but we focus just on the body of information that we arrive at through those processes. Maybe that on that second project, the distinction makes more sense, or is more significant than on the first.
Yeah, but I don't really see how that can work, because if somebody knows, there's always the question, how do they know? And maybe what you were suggesting is something like, well, there are certain propositions whose content is, as it were, kind of preempts any issue about how they got there, and so that, roughly speaking, these would be contents such that if you believe them, then, or ipso facto, you know them, or something like that. But I don't think there can be any such contents, because here's a kind of thought experiment. Suppose that somebody has a guru, and they just believe whatever their guru tells them, and their guru is basically a complete fraud, and just tells them stuff at random, and but they always believe it, and so on. And so for any content whatsoever, this person could believe it by having been told it by this super unreliable guru. And somebody who believed it in that way would not count as knowing it. And so what that indicates is that there's no content such that believing it is sufficient for knowing it. There's always some kind of condition on how you came to to believe it, which is relevant. And so I don't think that we can separate the question of, as it were, current epistemic status from how you got there. I mean, of course, there can be cases where somebody originally acquires a belief in some sort of bad, irrational way, and then later on they kind of find out that there is a proper justification for this, and then their belief in the same thing can have an improved epistemic status, because as people sometimes say, they've rebased it on, but that's in effect, they've come to know it on a new basis. It's just that they previously did believe it, but on some other basis. And so if we, but those are not cases in which it's irrelevant how they came to their belief. It's relevant how, as it were, they've come to their present belief, which may not be how they got to their prior belief in the same thing. So I don't think that we, as it were, we can ever make the cognitive process just totally irrelevant. It's always a factor in the status of our belief.
I see. Thank you very much.
Okay. We also have William, I think.
Yeah, thank you. This is really, really interesting. So I think what my question was originally very similar to Eduardo's. So I'm going to have to edit a little bit, and it may no longer be dialectically effective. We'll find out. But my question was about, there does seem to be a distinction between, at least in mathematics, certain proofs that maybe or certain mathematical truths that we can just, intuit, as people say, certain proofs that maybe we can plausibly just do in our head, right? Rather than having to appeal to some other long-winded cognitive process. I mean, presumably, I think this is why I'm trying to remember the example. You might think that Goldbach's conjecture is a posteriori, right? Because you have to go through all of the mental machinery to get there. We don't know right now. But if we performed the steps and so forth, we would eventually discover, this necessary truth that we found out by having to, engage in this sort of experientially conditioned process. And all I'd want to say is it seems to me that there is something interesting about that subset of mathematical truths, right? Maybe even 2 + 2 make 4 or something like that, that separate them from those that we can't come to know just on that basis alone, right? Whether or not that's a super reliable way of getting at those sorts of truths, I'm not sure, but it does seem that there's something interesting about those. And I'm wondering if that's a possible direction that you might take in recarving this distinction between the a priori and the a posteriori. Does that question make sense?
Yeah, no, it makes sense, but I'm just not sure that it's cutting at the right place, because it looks as though the ones that we can do in our heads, those are just the comparatively simple ones, the ones where not much processing is involved. I mean, with 2 + 2 = 4, the thing is, probably that's just something that we remember. but of course, there are various not too difficult additions that we can do in our heads, and of course people vary enormously in how much they can do in their heads. But I don't think that tells us very, very much beyond the comparative simplicity of what's involved, and the line between what you can do in your head and what you can't is that's very, very variable, not just between people, but it's also it depends a lot on how much mathematical experience you've had. But so, you know, I don't. You know, I'm not sure that corresponds to anything of great epistemological significance, because, you know, what we've got is, roughly speaking, a continuum of complexity, and, you know, in our heads we can get a bit of the way along that continuum from the most simple end. But that, you know, that doesn't show that there's, as it were, any kind of joint between what we can get to and what we can't get to. I mean, you know, it would be, you know, imagine if we were doing maths on a beach, and the only, you know, we were writing things down, but they had to be written in the sand, and then, you know, then we had to run around and, you know, look, and so there'd be a limit to what, you know, what we could do on this beach and what we couldn't do. But that would just, you know, and it would be sensitive to, you know, to stuff like how dry the sand is, and what the state of the tide is, and all these kind of things, and we wouldn't expect to be getting at any very deep epistemological distinction there between what we could do on the beach and what we couldn't do on the beach, and in the case of what we can do in our heads and what we can't do in our heads, I don't think it's actually so different from that. So there's a distinction. But I think it's just a distinction that, you know, that has to do with, as I say, stuff like short-term memory and things like that, very, very contingent features of human cognition.
Okay. Could I have just a quick follow-up before Gabby?
Sure.
Okay. Yeah, I guess what was underlying my question originally came from your discussion of like superhumans, right? And so what you said was that, you know, if we found out, say, that, you know, in principle, they could, you know, do these things in their head, right? That would be a fact about them, right? It wouldn't be particularly interesting for us, right? But I guess one thing I'd still want to say is that if I discovered that that was a fact about them, right, I've discovered something interesting about their epistemic lives, right? I've discovered something interesting about, you know, where they have to start off, what the justificatory grounds for, you know, their performing mathematics are. And maybe that is sort of analogous to, you know, what beach they're on or something like that. But I'm still inclined to say that, you know, if I turn it to myself, or, you know, humans generally, why I shouldn't say that that wouldn't be an interesting fact, if it's an interesting fact with respect to what I discover about the superhuman.
Yeah, I mean, it's, you know, it's an interesting fact about, for example, you know, the more or less untutored Indian mathematician Ramanujan, that he could do amazing things in his head. I mean, you know, he was extraordinary, but you know, but I just don't think what one can draw that much in the way of, you know, of epistemological conclusions from a case like that. I mean, he was, you know, 1,000 times better than most of us are in you know, at doing certain tasks, but it wasn't, he wasn't doing them by magic, or, you know, it wasn't, he wasn't using, I assume, as it were, something that other people don't have in some degree.
Okay, thank you much. I also sort of wanted to mention my favorite pet theory on mathematical intuition. So people, you know, like Gödel and stuff, they say, like, you know, we have this mathematical intuition where we peer into the mathematical universe and so forth. And my pet theory has always been that Gödel did. that Gödel actually had that, but that, you know, us mere mortals don't.
Well, if you read his biography, it's very clear that you're dealing with a mere mortal. I can assure you. I think his favorite film was Snow White.
That's interesting.
I mean, I don't know that shows anything about his mathematical ability, but he really was very, very human in some way.
I also have a quick follow-up on the previous question and Eduardo's question, which is, so you say that there is like no epistemic relevance on this a priori, a posteriori distinction, but I was wondering whether there is some dimension of epistemic evaluation in which that might be like relevant. So for example, if our ideal dimension of epistemic evaluation is knowledge, then maybe it's not relevant, but one may say that if we are considering some other dimension like justification, warrant, entitlement, maybe in those cases, the a priori, a posteriori distinction might be relevant. So yeah, that's my question.
Well, of course, you know, if it's not relevant to knowledge, then, you know, given my knowledge first approach, you know, that everything centers on knowledge. So, you know, I'm not really going to say that there's something else that of much importance in epistemology that it is relevant to, because knowledge is, as it were, the central thing around which everything else is organized, as far as I'm concerned. I mean, the thing is, what I was hoping to do with the examples was just to emphasize how similar these things are. So how similar the case of knowing by proof is to the case of perceptual knowing, and so I mean, it wasn't crucial for that comparison that we thought in terms of knowing. I mean, of course I do, but if you just look at the cases and what's going on in the cases, they just seem such similar cases that it's, you know, it looks as though any kind of epistemic distinction between them, I mean, then you know, it's going to be comparatively minor. But I mean, it's not as though when you look at the cases, some other kind of difference jumps out at you. So, you know, so I don't really see a basis in these cases for saying that there's some other epistemological dimension which is not knowledge related, on which they're miles apart. I mean, I don't see what that would be. I mean, it's just not something that strikes one when one looks at the cases.
Okay. Tim, do we have question? Do we have time for one more question?
Yeah, look, I don't have a special time constraint, so I'm happy to go on taking questions for a while. So,
okay.
Yeah, Gabby should get a chance to ask his.
Thank you. Yeah, sure. So Gabby, go ahead.
Thank you so much. Yes, and thank you for your presentation. I also wanted to to push in this general direction where it seems that the audience is going, and I want to try and argue for something a bit more concrete. I've been thinking a lot about the place that sort of pattern recognition has taken here, and thinking a lot about, you know, chess positions and identifying patterns also in the more ordinary world. And I find it interesting that beyond just seeing a pattern, there's also it is required for one to derive something from that pattern, that one applies a certain inferential set of rules or some set of rules, right? So to determine that that black has mating 3, one also has to not only just see the pieces and their arrangement, but also what the rules of chess are. And so perhaps one could attempt to trace a line between a priori and a posteriori knowledge by focusing on 2 aspects or features of an instance of pattern recognition. One feature being the saliency of patterns, right? Given our psychological constituencies, like some patterns are more salient to us. And then perhaps some set of rules are more natural, so to speak, to apply, right? In the sense that, for example, pre-Phrygian logicians might have thought they were capturing the structure of thought, right? Maybe this is not exactly true, but maybe what they did was they were in the business of applying a set of rules which somehow humans are more constitutively apt to be applying. And so, like, a priori knowledge would be the sort of deliverances of pattern recognition that emerge from very natural to detect patterns, interpreted in this sort of natural way, which, I don't know, maybe it's uninteresting that this, because it's very psychological, it's a distinction, but I find it that it might, trace an important line.
Yeah, but I'm not sure that it would correspond to the kind of things that epistemologists are interested in. I mean, for example, something that I think the psychological evidence is very strong, and the neuroscientific evidence is very strong on, is that recognizing faces that's very, very deeply built into human psychology, and there are we're structured it to do that, and so so that as we're classifying something as a face. That is one of the most natural distinctions that it's possible for a human being to make. But it doesn't seem as though, if that comes out on the a priori side, then the a priori is something very, very different from what epistemologists had in mind. And I don't think that's just an anomalous case. I think that for example, another thing that seems very, very, very basic for humans is to distinguish between living and non-living things. So, we're really wired up to make that distinction. And again, that doesn't seem to be anything on the a priori side. Whereas the kinds of distinctions that we're making when we recognize, for example, instances of modus ponens. I mean, those are the kind of distinctions that, they come naturally to someone who's been taught to read, but reading doesn't come that naturally to human beings, and I think. It might be that. So, someone who had not been taught to read might have considerable difficulty in recognizing written modus ponens. So, I certainly agree that some distinctions are more natural for human beings than others, but I don't think that will get you a line that goes anywhere like that between the a priori and the a posteriori.
Thank you. Yeah, that's important to remember. Thank you.
Okay, is there any other question?
Maybe I can take advantage of Tim's
Oh,
generosity.
Yeah.
and ask a very, very, very open and vague question, which is, what consequences does your view have on Benacerraf dilemma? It seems that you are completely dissolving the the problem there? Is there a way to reinstantiate that problem as
yeah? So the thing is, the way Benacerraf formulates his dilemma, it requires something like a causal theory of knowledge, which was, maybe it felt that was the way things were going, in the late 1960s. I mean, that was when, the kind of classic Goldman paper about the causal theory of knowing was published and so on. But if you look at subsequent epistemology, you don't really have causal theories of knowing anymore. I mean, of course, all epistemologists agree that causal connections, in some way can be epistemologically relevant as they are in perception, but it's not. There isn't, an outright causal requirement on knowledge, and if you think again about how we might originally engage with kind of proto-mathematical things, so that we can do things like recognizing that there are 2 apples in the bowl and recognizing that there are 4 apples in the bowl, and when we do that, there's some kind of causation is playing some kind of an underlying role, but it's certainly not cause. It's not that the number 2 is, as it were, is kind of knocking on our head or anything like that. It's that a state of affairs characterized in numerical terms, is having an effect on us, and so that we can there's no great obstacle to getting to know some facts about the external world which are characterized in numerical terms, and then of various processes of abstraction and abduction and so on from those, may be able to take us to knowledge of mathematical matters. So I don't really think that that Benacerraf's Benacerraf style objections are very strong. And I mean, just to give you another kind of example where people have tried to use that type of dilemma, which it would be the case of a moral epistemology, and then people say things like, rightness and wrongness have no causal powers, and so we can't know anything about the moral if we're going to be realist about morality. But again, that doesn't preclude that we can have some kind of pattern recognition for rightness and wrongness, just as we can have pattern recognition for certain small numbers of things of a given kind, and that's all you need to sort of get started, as it were, epistemically. And yeah, so I don't think that philosophers of mathematics are have been that impressed by the Benacerraf dilemma for quite a while. I mean, it was I think it's generally felt, I mean, you know, independently of the specific things that I was saying today, it's generally felt that it depends on, you know, too simplistic a conception of knowledge to be really effective.
Thanks.
Good. So any other questions? Okay, so it seems there are no more questions. Well, I would like to say thank you, Tim. This has been great, actually. It was a very interesting talk. I don't know if you can stay with us for a few minutes, and then I think we can like close the recording.
Yeah, I can stay with you for a few minutes if you like it. That's not a rush.